friends, how are you all today? Have you ever wondered what embedded systems are and how they are being used in the current technology? It's coming up right now. I'm Prashant. I'm a technical trainer and freelancer in Dharani Academy of Technical Education, Bengaluru. We'll start with the concepts of embedded systems now.
Uh, First, we see what are the differences between the embedded system and a general computing system. Okay, once we know that, we will come across the various points which differentiates the embedded system from a general computing system. Okay, all right. So on this side, I'll write the points corresponding to embedded systems. Okay, and on the other side, let's try to write some points related to the general computing systems. Okay, all right. Right. So point number one, under embedded systems, now basically the embedded systems include a combination of special purpose hardwares and a special OS operating system called embedded OS. Why? It is meant for execution of specific set of applications only. It's not general, it's very specific. Okay, so I just write here all right, it will be the combination of special hardware and I write dedicated embedded operating system. Okay, this is for a specific application. Application or applications. That's what is the characteristic of embedded systems. When it comes to the general computing system, right? Now we know that it's a general hardware. So general hardware, we call it as a generic hardware, contains a general purpose operating system, right? And you will be able to execute a variety of applications. Okay, so consider the difference between a general purpose computer, that's our laptop, and maybe you consider one of the specific embedded system such as a washing machine, right? See, both will have a processor inside inbuilt, both will have uh, the software corresponding to the execution of a task. But you see, general system or a general purpose computer, you can actually use it for several or variety of applications. You can install different softwares over there and you can execute, right? You can make it to work, right? So that hardware supports, right, generic version of hardwares, and it also supports a variety of softwares to be installed over there. Correct? Browsing ಮಾಡ್ಬೋದು ಅಥವಾ ಬೇರೆ ತುಂಬಾ ಕೆಲಸಕ್ಕೆ ಅದನ್ನ ಬಳಸ್ಕೊಳ್ಬೋದು. ಸರಿ ಅಲ್ಲ? That's a general purpose. When it comes to the embedded, such as the example I gave, washing machine, you see there are several inputs to be given. There are a lot of variables can be changed, but still you cannot make it to work for general purpose. It's a specific purpose. So specific hardware matra ide adralli, right? Whatever hardware you require to control motor speed, whatever the hardware required to control the water levels, etc. See, it's a specific. So you have to select special hardwares for them, and there will be a OS, right? There is a software which is a OS version, small version of the OS called embedded OS, which supports that specific task. Okay, so one simple difference between the general and the embedded, right? So that we understand what embedded is. All right, so let's write this point under the general computing system. Right, so this I can write it is say there is a combination. Once again, it is the combination of, say, we have two things. One is generic hardware and you have a general purpose OS. General purpose OS, right? Why? This is for you have to execute, for executing variety of applications. So we can write a program, we can run that, we can build an app for which acts like a calculator, right? I can do some projects. Idella general computers ಒಳಗಡೆ ಬರುತ್ತೆ. All right, right, first point. Next, you see, now who can write the programs over here, right? In case of an embedded system, right, I know that okay, this has computing capability, right? I program can be written ಒಳಗಡೆ ಒಂದು ಮೈಕ್ರೋಪ್ರೊಸೆಸರ್ ಅಥವಾ ಮೈಕ್ರೋಕಂಟ್ರೋಲರ್ ಇದೆ ಅಂತ ನಮ್ಗೆ ಗೊತ್ತಿದೆ, right? We know that we can program, but if I purchase a embedded device, right, maybe microwave oven, maybe, right, the washing machine, if I purchase, after purchasing I cannot write any program into that, correct? Right, at the same time, if you purchase a general purpose computing system such as a laptop computer, right, you definitely can write the programs, you can program them. So this is the difference, right? So this is we can write this is not the end user programmable. End user cannot write programs. At the same time, when it comes to the general computing systems, right, end user can write programs. End user programmable. All right, fine. So another major difference is that now what are the components present inside a embedded system that actually needs to be decided? We call it as a deciding factors, right? Is actually this, it's very specific to what application you are building. See, the hardware that is present inside embedded system varies from application to application. What you use for a microwave oven, you cannot use the same thing for any other device such as washing machine. Okay, so this is another difference. But when it comes to the general computing system, right, the deciding factor is how good performance you want from that. Okay, general purpose computers or general computing systems you select the components, hardware components, based on what type of performance you want, right? The processor's capability is the only criteria which decides what components you want inside your computer. Like the processor number i3, i5, i7, i9, or if you go for a different company, maybe AMD, you select a different, right? Ryzen 3, Ryzen 5, Ryzen 7, and so on. See, that is a factor which is deciding what computing capabilities you want to include in the general purpose computer. Whereas the components you select for embedded is decided by what type of application you are using, not the performance wise. All right. So we'll write here the key deciding factor, right, is, we can say, the application specific requirements. They decide what components will be present at the same time, right? So over here, the key deciding factor is the performance. Then let's go to the next one. Now, when you try to go for a general purpose, we need a very specific or a very critical factor called time of response, right? In a sense, you have to design the system such a way that the whole computing system responds within a time, irrespective of what code you write. Okay, there is a specific design criteria called response time. That is very critical when it comes to general computing system, because you are designing the system for a general purpose, general usage. Anything you write, it should be right handled very well by the hardware and the software combination. Whereas on the other side, when you go for a embedded system, right, the design will never look at the uh, response time, because it is applicable only for one time. You decide and you design it, that's done. You don't have to check that for each and every type of software that you may install, because you are not going to do that, right? So that's the next point, right? We'll write, okay, this is the point, the response time. Okay, response time uh, may not be critical, may not be a may not be a critical design issue. Okay, but on the other side, so here the response time is a critical design issue, right? Why it is this critical issue? Because you are going to install several softwares, each and everything will have different uh, response time, and you should be able to handle, right, that situation. Are you okay? Let's go ahead. Right. Now, since you are designing a system for very specific application, you can predetermine how the system is going to behave under different values of inputs, right? For example, if you set the input water level to a specific amount, okay, specific amount of water level, and you choose specific type of program of execution, right? In a sense, you may select maybe mixed clothes, woolen clothes, etc. When you select the input options in a washing machine, right, we know that how much time it's going to take and what will be the cleaning level of that particular machine, provided you know what are the various features of what is the RPM, right? What is the water pressure, right? Etc. If you know, you can determine, right, the specific outputs of the embedded system. Okay, when it comes to the general purpose, right, it is not known, right? I know I have a i3 processor or i5 processor, but for a given program, how much time it is going to take, right? You cannot predetermine that. It depends upon various other parameters, like what are the other programs running in your computer, because are you supporting multiple works at the same time, right? Multitasking, are you supporting, right, etc. All other features, right, will decide the time required at that given moment of time, okay, when you execute that. So this is the another major difference. So here we can say that the behavior execution behavior is deterministic. You can determine the other side. Execution behavior is, you cannot, is not deterministic. We cannot find that, right, beforehand. Okay. Now, so this point we already know, so let's not discuss anything about it. Directly I'll write. So this actually runs, right, very specific applications known at the time of design. Whatever applications are known to the embedded system at the time of its design, it will run only those applications, not anything else. You cannot install something at later. Okay, so here this runs all applications, right, installed at any point of time. So it means you don't have to install it, right, at the time of manufacturing. You can install it later and you can run. All right. Now, how do you differentiate different embedded systems? So far we said that, okay, for an embedded system, right, the design criteria is something like what application you are using. If that is the case, then all the microwave systems should be of same price, right? Why do you have a differentiation? So there are differentiating features always. Okay, differentiating features corresponding to embedded system include the following. Okay, we'll write the differentiating features are, first one is power. Okay, what power? you want to give it. So depending on the power, you have variations in the model as well as pricing when you go for the embedded system such as microwave oven, right? Okay, next one is same thing. This relates to the cost, right? Relates to the size. What is the size and what is the speed of operation? These are the various features, right? Now you see here on the other side, the differentiating features basically are speed, the cost, and software compatibility, because you want to install different softwares. Compatibility, right? So depending on all these, right, we will be able to differentiate the general purpose computing system or a simple computers. All right, go ahead. Now let's try to define, therefore, what is an embedded system. So now we understood that the basic criteria behind embedded system is that it's a system with a set of maybe interacting components, hardware, uh, for a specific. Actually, it has a fixed plan in the sense you select water level, you select speed, okay, it starts working, right? Similarly, you change it, change the values, right? It starts working in a different way, right? Like that. So it has a very specific working plan, specific set of inputs. All right. So now we try to write the let's write a definition like thing, because normally this is an important question that define. Okay. Uh, so embedded embedded systems. I'm trying to write a definition of it. Embedded systems say are the computing systems with we say that tightly coupled hardware and software integration designed to perform a dedicated function. A dedicated function. So here we understand that the word embedded basically reflects a fact. These systems are usually the integral part of some larger system. Okay, because you see that this is embedded inside something, right? You have a bigger machine, right? Bigger machine called maybe a washing machine is a bigger system, but the embedded computing part inside that is what we call as a embedded system. So it is embedded inside a bigger machine. Okay. Now there is another version of embedded, right? A machine which is bigger can have multiple computing systems. Again, they are embedded only, right? Each embedded system can be designed for specific tasks that the whole bigger machine performs. For example, the vehicle has an embedded system, right? Vehicle has a computer. Vehicles will have definitely computers present inside them. right? That consists of multiple embedded systems designed together to give different informations to the driver and communicating with the outside world, etc. So you have a tire pressure monitoring system, which is one embedded system. It does a single job. You have the automatic AC, it's another embedded system. But you see that as a whole, right, multiple embedded systems are coexisting inside the vehicle. All right. Okay. Now, we understood that the embedded systems cover a large range of computer systems from, right? So far we understood that we have very small computers doing a embedded task, and a very big computers also can be present inside a bigger system, and we call them as embedded systems. Embedded systems can be built by using small computers to big computers, right? Small computers in the sense microcontroller, microprocessor, and big computers are the supercomputers. Okay, right. Now we'll see what is a general view of a embedded system. So embedded system, when you want to design, right, we'll be having the following general view. You have what is called as a system input. System input. Now, so system input is given to, let us say, we'll write a block. Inside this block is what we consider as the embedded system. Okay, right? We have uh, two major components, right? One is the software, and one more should be the hardware. Okay, so this side we have the software components, and on the other side we should have the hardware components, right? And there will be an interaction always, right, between those two. So it's a double arrow indicating that there will be an interaction between them. Okay, and what are the outputs? Outputs can also be marked in the same way. This is system output. Okay, overall this block diagram represents a general view of an embedded system. Okay, so from this we will be able to understand the following points, right? It takes some inputs, right? It will be processed by the hardware and the software components, right? Specifically selected hardware, specifically selected softwares, all together do the job, right, and get you some output. So let's write few points here, because when the question comes about explain the general, define and explain the general system, we need to write some points, right? Okay, let's write them. So the embedded systems are They are the information processing systems, right? Which are usually embedded uh, into some larger product, right? And normally we don't see these components uh, from the outside world. In the sense, they are not directly visible to the user. This computing system is not available, right? We don't see the computer that is controlling the working of a washing machine or microwave oven, etc. Right? That's the point. Hmm? So processing systems, we can write that are embedded into a larger product. First point, uh, and not directly visible to the user. It's obvious. Correct. Now, in most of the cases, these embedded systems are something like very real-time based hardware, real-time systems we call, right? Again, you see that these embedded systems are normally working either on some safety-related issues, applications based on safety, or they have some mission to finish the job within time. That's called as a critical systems, etc. Okay, so these are the other characteristics which we have not discussed so far, right? We'll just make a point of it. Okay, so other characteristics of embedded systems are, maybe the first one is that they are real time. They are working always in real time under the current scenario, current inputs, and current values of the variables set, right? They are going to produce the output. Okay, so for the best example is that whenever machine is working, water input stops, right? What happens? It's going to generate some signal which is real time. As soon as water stops, cuts off, it's going to say that, right? It's going to generate a warning saying that there is no water. So that's what is real time. Okay, and the another feature is right, maybe the safety oriented. Always look for safety when you design that. And the next feature could be, right, we can call it as a mission critical, in the sense you have some time, within that time you are supposed to finish some job, like that. There is a time related uh, criteria for the working or the application of embedded system whenever you design.
That's all for the day. Feel free to contact if you have any doubts related to any topics in engineering. We can also help you in solving your assignments, projects, and many more. Thanks for watching. Good day.